Hello my lovely students, you are welcome to a new lesson. Today I shall be teaching you trigonometry and we shall be looking at the cosine rule. The cosine rule is used for solving triangles which are not right-angled triangles, in which two sides and the included angle are given. The cosine rule can also be used to calculate the angles of a triangle in which all three sides are given. Let's learn more about the cosine rule. In any triangle ABC, the angles are usually denoted by capital letters angle A, angle B, angle C, and the sides opposite these angles are denoted by small letters side A, side B, side C, respectively. Now let's see the cosine rule equations for triangle ABC. The first cosine rule equation is A squared is equal to B squared plus C squared minus 2BC cosine A. The second cosine rule equation is B squared is equal to A squared plus C squared minus 2AC cosine B. The third cosine rule equation is C squared is equal to A squared plus B squared minus 2AB cosine C. Please take note of the patterns of these cosine rule equations used for solving for side A, side B, and side C. Please note that we can transpose these cosine rule equations to solve for angle A, angle B, and angle C by making cosine A, cosine B, and cosine C the subject of these cosine rule equations. When we do this, we are going to have the following equations or formulas. Equation 4. Cosine A is equal to B squared plus C squared minus A squared divided by 2BC. Equation 5. Cosine B is equal to A squared plus C squared minus B squared divided by 2AC. And equation 6. Cosine C is equal to A squared plus B squared minus C squared divided by 2AB. Please take note of these cosine rule equations. Once again, for the cosine rule, formulas 4, 5, 6 of the cosine rule can be used to calculate the angles of a triangle in which all three sides are given. Please take note of all these cosine rule formulas. Please, let's see our first example for the cosine rule. Example 1. In triangle ABC, side A is equal to 3 centimeters, side B is equal to 2 centimeters, angle C is equal to 80 degrees. Find side C. The diagram for question 1 is shown below. Please, can you state the cosine rule formula that is required to solve for side C? Let's see if you can. Let's see the solution to question 1. From the question, A is given as 3 centimeters, B is 2 centimeters, angle C is 80 degrees, while side C is the unknown that we are looking for. Now, using cosine rule to find side C, this is the formula required. C squared is equal to A squared plus B squared minus 2AB cosine C. I hope you got that formula right. Let's substitute values into our cosine formula to solve for side C. We are going to have C squared is equal to 3 squared plus 2 squared minus 2 times 3 times 2 times cosine 80 degrees. Solving the equation carefully, we are going to have C squared is equal to 10.9168. Of course, to get side C, we are going to find the square root of 10.9168. That gives us C is equal to 3.304 centimeters. I hope the solution to question 1 is clear to you. Moving on, let's see example 2. In triangle XYZ, x is equal to 5 centimeters, z is equal to 3 centimeters, angle y is equal to 102 degrees. Let's find side y. The diagram for the question is shown below. Once again, can you state the cosine rule formula that is required to solve for side y? Let's see if you can. Let's see the solution to question 2. From the question, we are given that x is 5 centimeters, z is 3 centimeters, angle y is 102 degrees, and side y is unknown because we have to find side y. Using cosine rule to find side y, this is the cosine rule equation. We have y squared is equal to x squared plus z squared minus 2xz cosine y. I hope you got that right. Let's substitute our values into our equation for y squared. When we do that, we are going to have y squared is equal to 5 squared plus 3 squared minus 2 times 5 times 3 times cosine 102. Of course, 5 squared is 25, 3 squared is 9, minus 2 times 5 times 3 will give us minus 30, but cosine 102 will give us a negative value, which is minus 0.2079. Solving on, 25 plus 9 will give us 34, while minus 30 times minus 0.2079 will give us a positive number, which is plus 6.237. Please take note of this change. So adding your values for y squared, we are going to have 34 plus 6.237, which will give us y squared is equal to 40.237. Of course, to find y, we are going to find the square root of 40.237. That gives us y is equal to 6.34 centimeters. I hope the solution to question 2 is clear to you. Moving on, let's solve our third example. Example 3. Calculate the angles of triangle ABC with sides of length 4 meters, 5 meters, and 7 meters. The diagram to the question is shown below. Let's see the solution to question 3. From the diagram, we are given side A is 4 meters, side B is 5 meters, while side C is 7 meters. These are the sides opposite the angles A, B, and C respectively. Don't forget, angle A, angle B, and angle C are unknowns because we are looking for these angles. So firstly, let's use the cosine rule to find angle A. Can you state the cosine rule required here for cosine A? Let's see if you can. The cosine rule formula for cosine A is cosine A is equal to b squared plus c squared minus a squared divided by 2bc. I hope you got that formula right. Substituting your values into this formula, you're going to have cosine A is equal to 5 squared plus 7 squared minus 4 squared divided by 2 times 5 times 7. Solving this, we are going to have cosine A is equal to 58 divided by 70, which should give us cosine A is equal to 0.8286. To find angle A, we are going to find the cosine inverse of 0.8286. That should give us angle A is equal to 34.04 degrees. I hope these steps are clear to you. If they are, let's use the same method to find angle B. Using cosine rule to find angle B. Once again, can you state the cosine rule formula required here for cosine B? Let's see if you can. The cosine rule formula required here for cosine B is equal to a squared plus c squared minus b squared divided by 2ac. I hope you got that right again. Let's substitute values into this formula to get angle B. We are going to have cosine B is equal to 4 squared plus 7 squared minus 5 squared divided by 2 times 4 times 7. Solving this carefully, we are going to have cosine B is equal to 40 divided by 56. That gives us cosine B is equal to 0.7143. To find angle B, let's calculate the cosine inverse of 0.7143. That will give us angle B is equal to 44.42 degrees. I hope these steps are clear to you. Now that we have found angle A and angle B, let's move on to calculate for angle C. To find angle C, of course we can use the cosine rule method for solving for cosine C. But let's use the faster method, which is solving for the sum of angles in triangle ABC. Of course, we have angle A plus angle B plus angle C is equal to 180 degrees. Talking about the sum of angles in a triangle. This will give us angle A, which is 34.04 degrees, plus angle B, which is 44.42 degrees, plus our unknown angle C, to add up to 180 degrees. Now, do you know what we must do to get angle C? Let's see if you know. To get angle C, we are going to make angle C the subject of the equation. That gives us angle C is equal to 180 degrees minus 34.04 degrees minus 44.42 degrees. Angle C is equal to 101.54 degrees. I hope the solution to question 3, they are all clear to you. Moving on, let's see the applications of the cosine rule. The cosine rule has many applications to real life situations, such as in number 1, bearings, number 2, distances, number 3, angles of elevation, and number 4, angles of depression. For bearings, let's see the types of bearings. The first type of bearing is the compass bearing, which involves the north, the south, the east, and west directions. While the second type of bearing is the 3-figure bearing, which is measured from the north in a clockwise direction. Please take note of these facts about the types of bearings. Let's see our last example, which involves the application of the cosine rule in bearings. Example 4. 3 towns A, B, and C are situated so that the length of A to B is 60 kilometers and the length of A to C is 100 kilometers. The bearing of B from A is 60 degrees and the bearing of C from A is 290 degrees. Let's calculate. Question A, the distance of the length of B to C. Question B, the bearing of B from C. The diagram for the question is shown below. Let's see the solution to question 4a. From the diagram, in triangle ABC, let A be equal to the length of B to C, which is unknown. Let B be equal to the length of A to C, which is 100 kilometers. Let C be equal to the length of A to B, which is 60 kilometers. Now the angle A in triangle ABC is equal to the angle CAB, which is equal to the angle 60 degrees plus the angle 360 degrees minus 290 degrees. That gives us angle A in triangle ABC to be equal to 60 degrees plus 70 degrees in the diagram. That will give us angle A is equal to 130 degrees. Moving on, using the cosine rule to find side A, can you state the cosine rule formula required here? Let's see if you can. The cosine rule required here is A squared is equal to B squared plus C squared minus 2BC cosine A. I hope you got that right. Substituting your values into this cosine rule formula, we are going to have A squared is equal to 100 squared plus 60 squared minus 2 times 100 times 60 times cosine 130 degrees. When you solve this equation, what will be your answer for side A? Let's check out your results. Solving the equation, we are going to have side A should be equal to 146 kilometers to 3 significant figures. I hope you got that right. Looking at the solution, A squared is equal to 100 squared, which is 10,000, plus 60 squared, which is 3,600, minus 2 times 100 times 60, which should give us 12,000, while cosine 130 degrees should give us a negative value, which is minus 0.6428. Adding 10,000 and 3,600 will give us 13,600, while multiplying minus 12,000 and minus 0.6428 will give us plus 7,713.6. Moving on, adding 13,600 and 7,713.6 will give us A squared is equal to 21,313.6. To find A, of course, we are going to find the square root of 21,313.6, which will give us 145.99 kilometers. To treat significant figures, A, which is equal to the length of B to C, should be 146 kilometers to 3 significant figures. I hope the solution to question 4a is clear to you. Moving on, let's see the solution to question 4b, which talks about calculating the bearing of B from C. To do this, let's use the sine rule to find angle C. The sine rule formula required here is side A divided by the sine of angle A is equal to side C divided by the sine of angle C. If you substitute your values into this sine rule formula, what are you going to get as the value for angle C? Let's check out your answer. Substituting your values into the sine rule formula, we are going to have side A, which is 146 kilometers, divided by the sine of angle A, which is sine 130 degrees, should be equal to side C, which is 60 kilometers, divided by the sine of angle C. Don't forget, angle C is unknown. Solving this equation by making sine C the subject of the equation, you are going to have sine C is equal to 60 kilometers times the sine of 130 degrees divided by 146 kilometers. Solving this, you are going to have sine C is equal to 0.3148. Of course, to find the angle C, we are going to solve for the sine inverse of 0.3148. That should give us angle C is equal to 18.35 degrees. I hope you got that right. Lastly, from the diagram displayed here, talking about the point C in triangle ABC, the bearing of B from C is equal to angle NCB. From the diagram, looking at the straight line going through point C and A extending upwards, we can find that the angle 70 degrees plus the angle NCB plus the angle 18.35 degrees should be equal to 180 degrees. Talking about the sum of angles on a straight line. Do you know what we must do to get the angle NCB in this equation? Let's see if you are right. Of course, to solve for angle NCB, we have to make angle NCB the subject of the equation. That gives us angle NCB is equal to 180 degrees minus 70 degrees minus 18.35 degrees. Calculating, we have angle NCB is equal to 91.65 degrees. Therefore, the bearing of B from C is 91.7 degrees to 3 significant figures. I hope the solutions to question 4 they are clear to you. Talking about the applications of the cosine rule in bearings. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic trigonometry involving the cosine rule, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.